effective API integration, part 3. Hopefully this is the final part, unless people want to hear more about this subject or subtopics under this. We've sort of run through numerous topics. I'll do a quick recap for people who haven't been to part 1 and part 2. I think the recording will be available on YouTube already for the part 1 and part 2 if people do want to go back and look at those. Just want to thank the different panelists that have participated in this. Today we're going to be hearing from Harry as well as Vaughn, but the other panelists have been there for the previous parts, if you like. We typically launch a lot of polls as part of these meetups, and just want to remind everybody about some of the polls and the results. We asked what is the biggest influence on ineffectiveness of APIs. By far the biggest winner was insufficient governance and not being able to follow standards. How difficult is it to name resources for APIs? Majority thought it was okay, but actually still a good majority, 37% of the participants thought that was quite hard. So we'll see if these sessions have helped a little bit as well. And what makes a team go faster, whether it was experience, use of patterns, automation, or voodoo. And that was interesting. And we had a little bit of a chat about each of these polls. And what we sort of talked about was putting semantics before schematic. So providing an abstraction that's predictable and providing value. We heard about reification, how to make your abstraction a little bit more physical, a bit more concrete. Again, if you weren't in that talk, I'll share the slides so you can go back and read through more details on that. And we found out, at least from experience from Lakshmi, the thing that impacted velocity was automation, not necessarily experience, because she gave us an example where she had an inexperienced team, but they were still able to beat an experienced team because the inexperienced team did a lot more automation in terms of velocity. So I thought that was a interesting kind of outcome or discussion. What I want to do the same thing today. I want to start with a poll.
Just on that, Jay, just on that point about patterns, if anybody who votes say they're not using it, they're probably using patterns, but not realizing it, given that MuleSoft already actually implement some very, very well-known patterns and well-documented patterns.
Absolutely. I think you're spot on there, Martin. Voting has stopped, so I'm just going to end the poll. Almost all the time, 43%. Every time, only 20%, which is quite interesting. But sometimes it's 34%. So I think we have a fairly good audience who are kind of familiar with patterns and likes to use patterns, which is good. One of the things that I want to say about the patterns is I think knowing the pattern is the start, because most problems have been solved before, but at the same time, using the patterns alone has some pitfalls as well. So you've got to make sure it's appropriate for the technology. You've got to know when to use the pattern. You don't pick the wrong clothes for the weather. Every piece of clothing is probably appropriate, but in the wrong weather, it might not make sense. So Harry, I guess you made a transition from kind of being a senior developer to an architect, and I know you're picking up and using patterns more and more, but can you share with us your journey around how you started to use patterns and how you're utilizing those?
Yeah, sure. So me, I've been in UK for the past 3 years now. So I was mainly working as a senior developer back in India. So I was more interested to do the development work and things like that. But so I was more concerned about more of an API. I was working more specifically to a particular API as such. So I was not knowing the complete picture. So when I came back to UK, I started to work with more architects. I got to know the complete picture about it. And then was the question that how will I start architecting solutions. So again, when I started to work with all the architects with whom I worked on, so one of the key main points what I got from each of them is basically that they start to look into patterns. Patterns are their kind of a dictionary which they use in order to provide any solutions. So the other advantage of using patterns is basically that what I've got to know from them is that since it's, again, as Jay told, it's a proven solution. So we always know that if you provide a solution for a particular problem, and if you're using a particular pattern, definitely we know that it's going to work. So that will give a lot more confidence as an architect as well. So going forward from there, for any problems, I always look out for patterns wherever it's possible. I have a catalog of what patterns are there. So any new patterns, wherever I find it interesting, I have a catalog. I keep adding it to the catalog so that will be a reference point for me to anyway start architecting a solution.
Yeah, thanks, Hari. What does anybody else have any other comments or any thoughts they want to share with the community around patterns? It's you know, a lot of people are saying it's sometimes you know, what kind of prevents you from using the said patterns in the first place, maybe?
It's other way, Devi, right? So see, if you are able to clearly map out your integration use cases, and then you are trying to convert your point-to-point into API-led architecture, then you will start with a position of mapping those use cases to the patterns and then implement, right? So, but if you take another scenario where the use case is quite new, or that particular solution architect or the API lead have not gone through that use case, then it is difficult for him to clearly map out a pattern, right? So it always depends upon the scenario, right?
The only sort of my 10 pence into it, and I think it kind of backs up what's just been said there, whereby sometimes the pattern has to be developed, the patterns have to be developed because within the situation, and develop the reuse depending on the company. Due to quick turnaround and delivery, you're often in the situation whereby you're kind of flying by the seat of your pants. As was said on the previous comment, if the requirements are not fully there, you know, your solution can't necessarily reuse a pattern because you're not necessarily getting the things like that.
Exactly.
So
So I meant to say that if your organization is matured in the API curve, whether it's in scalable or in optimization, that's where people start looking into how can I patternize, how can I fast things, how can I reuse. That's where patterns comes in. But if your organization is in a curve where it's just a startup, I think it's a bit difficult to think about the patterns at that stage, is what my opinion.
Yeah, absolutely agree.
So in the chat, Phil had said that an issue that he's come across is that patterns are not available in Mule version 4. They've all been created for Mule version 3. Don't know if anyone else has come across something similar.
Yeah, so that's a really good point. I've noticed that as well. You know, Mule version 3 kind of gave you a lot of the standard integration patterns out of the box and gave you implementations of those patterns wrapped up in little components, whereas Mule 4 is a lot more freeform. You've got probably more data weave going on, which is great, but that means that potentially you have to work a bit harder to actually implement a pattern. So we should still be using patterns, and if Mule is not giving us those out of the box, we still need to think in terms of patterns for our designs. Also, I think there's a couple of different layers of patterns. You've got kind of, you know, you've got architectural patterns, you've got you know, integration patterns, you've got patterns for writing and designing code, and depending on what part of your solution you're working on, you need to be able to know that the patterns exist, select the right ones, and apply them. So there are lots and lots of patterns out there that exist, and that sometimes need to be kind of tweaked to be more specific to a particular use case. There's also kind of business patterns. So a lot of people speak about patterns insofar as they work in a particular domain or, you know, organization, and over time they start to see patterns emerging at a business level. And there's ways of componentizing or identifying those patterns and creating implementations that are reusable as well. So there's different layers of patterns that we need to think about and know how to pull them together.
Just to add to that as well, it's a good point in the sense that patterns, we're not in a fixed sort of architecture. Things evolve, so as a consequence, patterns will go out of date naturally. As you say, the principles, the architecture principles behind a lot of patterns are still valid. As someone once said, it, about electric machines years ago, there's nothing's new in electric machines now. There's nothing really new in a lot of IT architecture. It's it evolves, but it's just say it's the weather's changing. I'm just still wearing the same flares, you could argue.
Yeah, absolutely. And I think it's a key point in terms of industrializing some patterns and making use of some of those patterns, because I do agree with Bala in the sense that you need to go through a maturity curve before some patterns are kind of industrialized and templatized and reused. But I do think from the get-go, there should be nothing stopping you to say, for the requirements that I do know about, these patterns are suitable. And actually, you've got to go through an evolution curve to understand whether they fit the requirement or not, and then kind of evolve that, if that makes sense. And that's I guess sort of my view, but I guess it's interesting to hear everybody else's, which definitely adds to the topic.
So just to add a bit more meat to the bones of that, I've found out in the sort of last week or two, there's an accelerator component that allows you to collect MI data or display MI data in MuleSoft 4, right? But apparently it's not supported by Mule. It's a new component, about 6 months old, but it's not supported by MuleSoft at this time. Now, going back to what we said in version 1, if we talked about poor governance, if within your organization there is a governance rule that says you will not use components that are not officially supported by MuleSoft, that pattern's out the window.
Yep.
But then again, when it's supported in 3 months' time, that pattern becomes valid. So, going back to the evolution of patterns, and they have to change. Hence the reasons why it's always good to apply them, but not necessarily apply them against a certain rules. And anyway, I'll let you get on. Sorry.
No, I think it's a key point, and I think it kind of brings me on to, I guess, my next point here. For example, a queue is a basic pattern in integration, but you can have multiple kind of integration or implementation details, right? It could be files in a folder, it could be Mule VM, you could be using something like ActiveMQ or Kafka. They, at a very high level, they do something very similar, but they have very, very much different integration focus and different capabilities. And going back to your point, one of these might be an approved piece of technology, but the other ones aren't. And in order to use a particular pattern in a certain way, you might have to go through a whole EA governance process to get that particular technology approved for use. So I do think that's an interesting comment that you bring up. And kind of speaking of patterns, one of the the patterns that MuleSoft advocate are obviously layers, kind of experience, process, system layer. So I'm interested to hear if people consciously break up the APIs into multiple layers. Very, very similar result to the last poll, I think. I think of API layers, as inputs and output of layers. You can look at the design from different layers perspective, presentation layer, data layer. Really, it's different levels of abstraction, and a particular layer focuses on a particular aspect of the solution, right? You do have to think about breaking it down and decomposing it, but some people do decompose it into layers. Other people kind of decompose it a little bit more vertically, etc. And the way I think about MuleSoft layers is really in this regards. The top layer is being kind of a tailored response. The middle layers as being orchestration or kind of sub-orchestrations that you want to repeat multiple times, and the system layer as kind of really abstraction layers for APIs. And I know, Vaughn, you've been doing this for a number of years. Maybe you could kind of share with us your perspective on this approach, any kind of hurdles or pitfalls you kind of run into, any kind of guidance and your thoughts on this?
Sure. So, I mean, if we take a step back, I think software has been architected in layers for decades. That's not necessarily a new thing. You know, there's good reasons for using layers. So grouping different responsibilities together is one of them. So kind of separation of concerns, kind of layer isolation. So having layers so that changes in one layer don't ripple through other layers. So it kind of helps with loose coupling, and also layers in some ways help us to model problem spaces and help us to reason more simply about what's going on. So when you're thinking about things, sometimes it's easier to think about something in a layer and to isolate it like that. So, you know, software has been doing that for years. API ecosystems can also benefit from having layers. MuleSoft have basically taken the good practice around layers and turned that into their kind of API-led connectivity approach. So obviously, I'm sure most people know about, you know, API-led connectivity. There's three main layers. So there's a system layer, a process layer, and an experience layer. And each of those layers has different roles. Breaking things down into layers is useful. And some of the benefits you get, so I think you mentioned this, Jay, you get each layer kind of forms an abstraction around the responsibilities of that layer. And that abstraction then in turn reduces coupling, and looser coupling means that you can make changes that don't ripple through the system. So that means that you can make a change in one place without having to make changes in multiple places. And that's obviously a time and a money thing. And then you can also work within layers without having to have knowledge of any other layer or even that another layer exists. So those are all like really important things from a design and a design point of view. I think one of the biggest enemies of writing any kind of code and particularly in integration kind of ecosystems is coupling. So it's really important to reduce coupling or have loosely coupled components. And I think layers, so they go some way to kind of help achieve that. That said, I have seen, I have been on projects before where people will create layers that they don't need. So I think it's really important that you understand the role of each layer. And if you don't need it for a particular use case, then don't use it. You don't have to have all three of those layers. There's an anti-pattern called the architecture sinkhole anti-pattern, which is basically where a request might travel through multiple layers of architecture, and all it's doing is being passed through from one layer to the other without actually doing anything useful. And that's kind of also pointless. There's no point in having these layers if they're not actually going to provide a function or provide a benefit. So I guess we could ask ourselves, do we need layers? Does having layers work? And I think there's probably two different perspectives to that. I can answer that. From an architectural level, definitely, like I've said, it helps us reason about the problem space, and it also helps us to allocate responsibilities of our solution into the right places, into the right layers, and potentially the right components as well. From a development perspective, I think the answer is probably a little bit more complicated. Writing separate APIs and services that conform to a particular layer is useful, but, and this is a big but, only if the implementation is done correctly. It's much simpler to think about something in terms of layers and to reason about it and to design it on paper in terms of layers. It's a whole different level of thing to actually implement something in clean layers. And I think that's often where implementations fall down, is that things are designed in terms of layers, but the actual implementation still introduces kind of subtle coupling, which then negates the benefit of having the layers in the first place. So yeah, it's really important that developers understand the technologies that they're using and specifically how to use interfaces and how to keep layers loosely coupled and separate and clean. Yeah, I think, yeah, that's all
I think that makes sense. Again, just like last time, anybody else want to share their views on layers or using layers as a architectural pattern?
Constraint, Jay. What I've noticed is one of our client is whenever they see layer as a kind of a budget overkill sometimes to start with. That I've seen in many of our, especially internal clients. They don't worry about process because in my experience, I've seen the process layer is very much needed where there's more reusability, but when you speak to the specific end client, they don't bother because when they pay for the APIs or pay for the interface, all they need is the data. So they don't need, they want to have a minimum budget, and that means we have to have minimum layers. Sometimes we are forced to have just one experience API and one system API, and they don't bother about process API. That's one of the aspects I would like to share.
No, I think that makes sense. So I guess what you're saying, Joy, is in terms of development budget and being able to spend developers' time building out these APIs.
Exactly. Yeah.
Okay. I think that's a fair comment.
Yeah, on that point, I mean, one thing I have noticed just about every single client is how they actually group endpoints can have all sorts of problems. And MuleSoft like to push forward this thing that, so for instance, system API, you group it based on a main resource. So you can have, say, something like an insurance system, also a home automation system, where potentially you've got a system that serves up 100 endpoints. So you could end up for a single subsystem, for a single backend system, you could have potentially 20 APIs going to it. One, that's very expensive. Also, it actually makes it very brittle as well.
Yeah.
And obviously deployment jobs are all sorts of costs associated, and that's something that's never handled. The other thing is calling the thing the process layer just seems inappropriate to me because you're using stateless APIs for a start. Generally speaking, you don't own any data itself. You're literally just transforming data and enhancing it. So calling it, say, something like either a business domain layer or a technical domain layer makes far more sense to me. And also the thing is, the process you don't have that much control about apart from orchestration. So knowing where the requests get routed to, for instance, and how you enhance the data.
No, I think that makes sense. Yeah, and you can see by my slides, I don't really call it process layer as well, because that's not how my mental model works, unfortunately, because I do think that layer is purely for orchestration and enrichment and various other things that you've talked about, Martin. So I think that does make sense.
Yeah, of interest, what do you call it then? Do you give it a name, or do you just call it, is that layer just given an API name?
I just call it orchestration layer, and I in the architectures that I build, at least I can, and the team can that I work with, the development team, I can clearly identify why a particular API is an orchestration layer, because it is coordinating activities across different systems, and I mean systems, not APIs, and it's also having to do one thing or multiple things that is no other API's responsibility, if you like. So if you've got it seems you're working in an insurance domain at the moment, but if you've got a rating engine plus kind of a policy, system, there needs to be something that coordinates both of those to build a quote, right? So you could have something that's a quoting orchestration or quote orchestration layer, and then in addition to that, you might have that quote exposed in multiple different channels. So you might have it on your digital channel, you might have it on a price comparison website, and you might have it on on a partner channel, etc. So it's then that's where you get the tailored response, where that quote is then being tailored for each of those channels. That's kind of very oversimplification of of an architecture that I guess Harry and I put together for an insurance client. But yeah, I think it's important to know the distinction.
Jay, I do want to mention on that front, as you said. So I think on the insurance front, as we talked about the various orchestration and enrichment that happens in the code process, just to share an experience from my end as well. So when we were doing it for life insurance, general insurance, or healthcare insurance, a lot of services are common. Things like a call credit service, which would be invoked across all sort of quote and buy process. So even if I recollect the old days of SOA web services, so back in 2010 when we designed the enrichment framework, we had sort of got a web service which was orchestrating calls between DVLA, call credit, and then it was actually going to pricing engine and giving the service back. So a couple of years ago when we did our rectification by transforming the same SOA services into API, it eventually came at the same, just the naming convention got changed, but essentially the idea of calling this orchestrating service as a process API, I think it remains the same. We didn't use the Mule platform, it was a Fuse platform, JBoss Fuse, but largely the concepts remain the same. So yeah, I do agree with your view on what you just said there. Yeah.
Thanks, Puneet. Thank you for sharing. So I've got one more poll that I want to launch. Do you find you have to resort to custom code? Yeah, very, very different to the last two polls in a good way.
Phil just asked, what do you mean by custom code? So just for anyone who didn't.
I think it's a good question. So if we're talking about a technology like Mule, it's when you have to kind of drop into Java to do something. You could argue, some of the things you might end up in data weave could be considered custom code, but what I'm talking about is having to build some sort of component outside of Mule and then kind of importing it in, etc. But if other people have other definitions they want to share, I'm interested to hear that.
So in one of our instance, we have JSON logger 4, where we have ability to mask the few fields that comes in JSON, and we do have whitelisting. It has blacklisting to blacklist the fields, but as per our requirement, we thought we'll do whitelisting, and that is where we need to write some additional Java class, and then again create a custom JSON for logger, just adding few more features to it. So I thought that is one of the custom code which we did recently.
So extensions to Mule functionality, except one of the things is when we're writing custom code, we need to think about what we want to do versus what the business needs us to do. As technologists, it's really easy for us to understand why a custom code is needed and what value it provides. But some caveat is, code is expensive to write and expensive to maintain. And a lot of this can be done with, Mule, for example, without having to write custom code or very little custom code. Based on a comment earlier, I'd be interested to understand if Mule 4, in your opinion, changes this and you're now you're writing more custom code, or you're still reusing things out of the palette. So maybe that's a discussion point that people have an opinion of. Any comments or questions on that?
I just want to make a comment on the custom code, if you don't mind.
Yeah, please go ahead.
So personally, I don't come from a Java background, and that makes it harder to do any Java work because I'm not a Java developer. And now in my experience, I've seen that most of the MuleSoft developers, not all, but most, have a Java background. So they're Java developers. And what most I've noticed they struggle when they first come to MuleSoft, they struggle with doing flows and working with that. We generate the custom XML behind the scenes, the configuration. So what they tend to do is to just write Java directly and not use Mule, which basically defines the purpose for what it was built.
Yeah, I completely agree. I have reviewed a piece of code, quite a long time ago, where somebody had a Java component, and in there they were starting to make database calls out and doing everything. So essentially, a Mule flow was basically a container for Java code, as opposed to using the database connector and various things like that. So I think that's an interesting insight. So thank you for sharing. I guess, Vaughn, I've got a question for you, because I know you're quite passionate about custom code and what it means from a cost and business impact. Can you share some experience of some of your kind of pain points around custom code, and how you think about leveraging existing patterns to build effective APIs?
Sure. So yeah, this is a topic that I'm passionate about, and it's because over the last about 12 years, I've seen the most common issue that I've seen in most MuleSoft implementations is people using Mule as a Java repository, writing a load of Java and using Mule as a runtime. Now, I think you've hit the nail on the head. The impact of that is code is expensive to write, it's expensive to maintain, it's expensive to change. So there's a cost implication. And more than that, there's also a time implication. It takes time to write code, to test it. And one of the biggest things that organizations strive for is agility, is being able to move quickly. And it's one of the most elusive things as well. And I think for me, and this is kind of my view, but the benefit of Mule is that it gives you a bunch of pre-written code that meets pretty much any integrations, pattern or scenario that you wish to deal with. The code it's been written for you, it's been tested, it's out in the wild. All you have to do is compose that code into something that works for you. Now, I think I've seen, fairly recently, I've seen a project where the custom code runs into tens of thousands of lines in a Mule application. And a lot of what's being done in there are things like database calls and things like serialization, which Mule can do, out of the box. And I think it's really important that if you're going to have Mule and you're going to pay for it, that you get the benefit out of it. And that rapid application development is one of the benefits if you use it correctly. In my mind, if you are writing lots of custom code in Mule, then you probably need to step back and ask yourself, is this code actually integration code, or is it code that can be moved into a separate service? And that service, somebody made the point, it doesn't have to be written in Java. You can then write a service in anything you like and potentially call it or wrap it in Mule. You know what I mean? So in my mind, most solutions that involve Mule should have a number of services that are doing business-related things that are being called from Mule and being orchestrated from Mule, and where kind of the mediation type of stuff, so transformations and that kind of stuff is happening in Mule. But if it's not mediation and it's not like specific integration kind of functionality, then a lot of that custom code should sit outside of Mule in other services that Mule can call. And there's also good reasons for that. Some of them are cost. Running things, if you're writing lots of code that's running in Mule, you're using your cores to process that code. And if you can move that out, you probably need fewer cores and it's more efficient. When should we be writing code in Mule? In my mind, there's a few scenarios. One is Mule gives us the ability to extend the runtime. So there are times where you might have a transformer, for example, that you need to write, and DataWeave, you can do it in DataWeave now. DataWeave is brilliant. But back in the old Mule 3 days, Mule gave you some abstract classes that you could use to write certain components. And those abstract classes gave you the ability to link those, what you were writing into the runtime, and you get the benefit of of what the runtime had to offer. I think I've seen a lot of custom code written that's not connected to the Mule runtime at all. And that's probably a good sign that maybe it doesn't need to be there. Conversely, I guess, is I've also seen people using Mule components and dragging them onto, into a flow without understanding how those components work and understanding what they're doing. So just because Mule has the components, there's still a responsibility for developers to kind of be aware of what those things are doing and how that's affecting the runtime, and making sure that they've got an appropriate number of instances and whatnot. But that's probably a little bit off topic at the moment. I'm not sure if anyone's got any comments on what I've said so far.
Well, just to add a bit of meat to the bone and stuff like that, you go back to other integrations and stuff like that, you end up in a situation whereby someone's written some custom code, for example, that just does something in an Access database to generate a report or whatever, things like that. Everyone leaves the bank. Support for this Access database just dwindles and dwindles till it's not even things like that. Only one person can run it. And as my boss had a rant at me the other week, and says, I hate that now because I end up having to pay someone out of house to come and run something because the downstairs system doesn't work and they're struggling. So I need someone just to go, click, runs it, and all this sort of stuff. So from a support going forward perspective and a cost going forward, it is a nightmare. I think custom code had its heyday, if you like, but it's gone. And a lot of people who still go for that, it's because of their background, their understanding, stuff like that. So again, for example, a slight aside, I've heard things whereby people architect whole systems, but because they're from a database perspective, a lot of the process is done in stored procedures. So everything is sort of, an abstract of stored procedures to run it and all this sort of stuff. But that's their background, that's where they come from and stuff like that. I mean, from a personal perspective, as blagging as some sort of as a solution architect, I see several streams of it, whereby if you're a programmer, you look at things in some way. If you come through the infrastructure leg, you look at things in a different way. If you come up the kind of business knowledge and all this sort of things, you have a different outlook and a different sort of way you do it. And it does colour designs and solutions, really. But anyway.
I think that's a really important point, because I think the role of a solution architect is to make sure the right things are done in the right layers and in the right technologies, which was kind of my point earlier about, you could have a queue as a pattern, but you've got to still pick the right technology to have that queue in. And if you don't, then you're losing out in what that pattern can offer, and you're kind of misusing it.
One of the things I was going to say was there's a few things to look at. If you are spending most of the time writing Java, then you need to step back and ask yourself why. If you've got classes with thousands of lines of code, or even hundreds of lines of code potentially, and you've got lots of those, you have to ask yourself why. As I mentioned, like stored procedures. I think we're in danger with data weave of going back to that, where everything is becoming lots and lots of data weave files that are being stored and called from Mule, and we need to be careful about that becoming a problem as well. Because data weave, I love data weave. I think it's really powerful and it's really succinct, but it's very easy to do lots and lots and lots of stuff in data weave, and some really complicated stuff and some business related stuff, which is not always, just because you can doesn't mean that you necessarily should. In my mind, most Mule solutions, or the Mule component of most bigger solutions, should be composed rather than written. You should be composing probably 90% of what you need, and maybe writing 10% custom code where you're extending something that Mule provides that you can enhance. And again, in my mind, any solution that you're writing, you should be able to go from like the initial design to an end-to-end running model in a few weeks. You might have stubbed out and worked out some of the services that are being called, but you should be able to compose something within a few weeks. If you're spending months and months and months putting solutions together, then potentially there's too much custom code going on.
Yeah, absolutely. So in terms of, across the three different parts, we covered quite a bit of ground. I think we talked about, the API interface itself, and in terms of how you think about abstracting your APIs, putting semantics before schematics, making it kind of predictable, providing a layer of abstraction. We also talked about APIs and how you might automate the deployment, the testing, etc. of those APIs can kind of increase velocity and get you to get feedback faster, therefore kind of improving the effectiveness of APIs. We also talked about, well, at least this session is about, knowing the pattern is the start. And as you heard, lots of discussion about patterns not quite fitting or people using the technology in an inappropriate way, how you could decompose correctly, how you could decompose incorrectly, being able to validate and verify which patterns to use, and problems using patterns because you need to get it past governance, or you need to get the right technology approved. We also talked a little bit about custom code and the impact that has, or the lack of clarity that brings when you're not using a pattern-based approach and you're bringing custom code. So I think that's an interesting set of topics that we covered over the last three sessions, really. What I do want to do is kind of thank all the panelists who have kind of supported this. I know not all of them are here today, but they have been all involved, across the different parts of this, these sessions. So I do want to thank them. Any questions or any further comments on the meetup, or any further comments on the subject itself?
Just a quick one for what Vaughn mentioned about data weave. What I have noticed the last two clients is people have been putting business rules into the integration layer with data weave. The problem is data weave is not well suited to that type of thing, and that actually, where I am at the moment, that's become a really, really big problem. A change that should have taken literally 2-3 days took 3-4 weeks. Another thing that was actually done, which was basically using an off-the-shelf component. If they'd written it in C#, they could have implemented the change within, I would have said 3 to 5 days, but they spent 3 months on it, and their MuleSoft professional services come to clean it up. So I think this goes back to the now and the hammer thing, that it's using the right tools for the job. And the customization should be an exception. So it goes back to the Maven thing, whereby you use convention over configuration over code. I'd say it's the same with MuleSoft. Is that most of the time you can use the stuff off the shelf without customizing it, but there are times where you want control. Another example I'd say is MUnit, and when they had the JUnit interface, I found you could do a lot more with JUnit than what you can with MU even still, and now they've taken that away. I think that was actually a step back in some cases. So I'm actually in both camps, I would say.
Yeah, the YAM unit is an interesting use, right? Because it's almost like the patterns and the capability that's in there isn't rich enough, you know? And with any language or any pattern, the language and the features of the language has to be rich enough. The vocabulary has to be rich enough to say what you want, to write what you want, right? And I think as users of that technology, the only thing we can do is feedback to say, look, these are the verbs and these are the features that I'm looking for in this language. Yeah, and I do agree. What made Mule 3 very powerful is its kind of ability to extend and SDKs, and you can build your own plugins, etc. So you could industrialize patterns that you need, which weren't generally available as well. And MuleSoft can be slightly behind the times in terms of patterns. I still haven't seen a circuit breaker yet. So and that's something that community's been asking for a while.
The circuit breaker, which you just mentioned, that is already there, out of the box support from Endpoint MQ.
Yeah, but you've got to use queuing as opposed to
HTTP, that is
right. So yeah,
that's right. Also, I wanted to add some more things. I could see the pain of writing Java custom codes way back in Mule 2 and Mule 3 in Vaughn's face when he was expressing explicitly about the custom codes and things like that.
Yeah.
Because I also went through those ages. But yeah, with Mule 4, definitely they have improved a lot. That was one of the main reasons I think they moved away from Java codes to data view codes, but again, looking at the custom codes, it's not just the code which is written within the APIs, right? It is around the APIs as well. So if you look at the policies, Mule support definitely some of the out-of-the-box policies. But there are cases where you have to write your own custom policies. That's also a custom code. So it's not that you can completely avoid the custom codes. It is on the basis of where exactly it is required, and then you need to identify how best you can utilize these custom codes.
I think that makes sense.
So on a Manchester MuleSoft meetup, I did a presentation saying how I hate layers. So you're welcome to Google that and find it on YouTube and all that sort of stuff. Point 2, Java custom code. Look on the positive side. It's not things like Scala or that, all these other sort of languages that you just want to punch. But anyway, there you go. And last point, going back to the hammer and the nail thing, I always remember my father trying to help me floorboard my attic, and when it came to screwing the boards in, he says, I'm going to take a Coventry screwdriver to this, and then smacked it with a hammer. So there you go. That's, you know, but he was from Birmingham, so what do you expect anyway?
Thank you for sharing. Any other questions? It sounds like we know what our next topic is. Why layers are a bad idea. What was your title, Bobby?
I hate layers.
I hate layers.
Nothing more than that. And again, it's not that I hate them. It's a specific slide that's as a way of explaining layers that people then take and apply and then poorly apply it. It's that. Yeah. It's really more than anything.
Yeah.
So it all comes down to the implementation again.
Yeah, absolutely. And not being too rigid about it. Again, it's about governance, it's about specifications, about rules, and you know, and again, it's, you know, we talked about patterns to solve problems. Again, there's a lot of stuff in it. You apply a solution to a problem using a pattern, but then it's only sometimes down the line you realize, I've made this slight error, maybe I should have done it this way.
Yeah, absolutely. And I think this goes back to the point Bala was making earlier, if he's still on, in terms of not knowing the full requirements. Therefore, you can't fully solutionize either. But at the same time, you know, one of the things that I do as an architect to move teams forward is I literally put a stake in the ground and go, here it is, can we build that? Why not? And then you get people coming back and saying, yeah, we can't do that because X, Y, Z, or we want this, that's not going to give us that. And then the team usually arrives at an answer, you know, that's kind of 80% there. But a lot of the time it's actually making a start and putting something up that you get there. Otherwise, you spend forever just in design phase and not moving forward, because sometimes you've got to move forward to get the feedback as well.
Yeah. Not having a pattern itself may turn as a pattern as well.
Yeah, that's kind of an organizational approach, but I think goes back to what Bobby was saying earlier, that, you know, most things in IT aren't really new anymore. You know, same way it's the same electrical components that are being composed together differently to solve different problems. And same way, I think, you know, there are evolutions of the patterns, but the patterns exist, you know. Everything from a simple facade, if you're in, you know, to kind of gang of fours and architectural patterns, etc.
One of the questions I had was basically, I heard from many people saying that in Mule 4, it is very difficult to implement the patterns, or at least when compared to Mule 3, it is really difficult to implement the patterns. Why do we think that? That was a really interesting question, what I wanted to understand actually.
Yeah, good question.
So my understanding is that the Mule 4 by default brings a lot fewer kind of default components in. So you have to add, you know, a lot more. And what there is to add, I think that the view has been that data weave is there to replace a lot of the pre-existing implementation. So data weave makes a lot of things very easy. If you think about taking a JSON file and transforming it to XML, to do that is trivial in data weave. It's brilliant. You don't have to write anything. It's basically one line, one short line, and you're done. So I think data weave has taken a very central role in Mule 4, and it's a double-edged sword, because it goes back to what we were saying before. It means that when you're writing your data weave, you need to make sure that you're writing integration logic and not business logic. You're not mixing the two. But also, I think it's a lot harder to identify or to mix patterns. It's possible in data weave to do in one script to do many things, and you could be doing, maybe a transformation and then something else, and calling a flow that's maybe, potentially, I don't know, updating a database or putting a message in a queue. You can do all kinds of stuff in there. And I think that there's a danger there, because the patterns aren't as isolated and as identifiable as they possibly are in Mule 3. And that's a generalization, because there are still patterns in Mule 4 that exist and that have been carried forward. But data weave, I think, it's extremely powerful, and I think it's a Spider-Man quote: with great power comes great responsibility. So, yeah.
Right. But Vaughn, don't you think that those flexibilities have been added to the data weave, but it is again left to the governance body or the architect to decide at what levels of data weave they need to use and what levels of connectors and things like that they need to use in terms of creating that using those patterns?
It is, and you're right. But in my experience, what's happening on the ground with the developers when they're writing code is often quite far removed from, the rules and the guidance that's put around that. It's very easy to write something on purpose or even by mistake that crosses those boundaries. And I think it's very difficult to define a bunch of general purpose rules that will govern what data weave is written, for example. So I think it puts much more of the responsibility on developers rather than on architects. So, in my mind, architects should be drawing the lines and going, these things don't cross, these things are isolated, and developers then follow that. Whereas I think more and more in general, there's more and more architectural and design decisions are having to be made by developers, partly just because of the pressures that developers are under and budgets, and partly because technology is making things easier to do, and it actually requires fewer people involved in the process. And unless you've got a really robust process with lots of checks and balances and good code reviews and good guidelines and all that kind of stuff, I think it's very easy to cross those boundaries.
I want to thank John at Third Republic, everyone who kind of contributed not only through the free series, but three aspects of it, but tonight as well. So thanks, Harry. Thanks a ton, Vaughn, as well. Some really good contributions there and filled in some questions. And as per usual, Jay facilitating it and answering questions as well. And thank you, everyone, for your support and contributions to it as well.